Okay.
Okay, we are going to start this second webinar of the DBCO project. I would like to welcome you all here on this webinar. I'm very sorry for if you listened to all the technical mess before, but that is a part of the virtual meeting system and getting used to all these online services. Anyhow, I think yeah, it will be a very interesting afternoon today. I just need to get used myself to all these functionalities. Okay, so the topic of the webinar today is about European biogas technologies and the adaptations in different countries. We are focusing today on Argentina in Latin America, as well as on South Africa in Africa. But first we'll have an overview on the technical issues in Europe. So as an introduction, I would also like to welcome the coordinator of the DBCO project, Johannes Anhorn, and Katrin van Leere. Also, Sincha Alema from ICE-ADIS from Ethiopia, who is supporting us and who is in charge of all these webinars. So I think I cannot see you, but I hope you are there. And also my colleagues, Felix Kollmorgen, who is organizing this webinar today. And Felix will be in charge of taking note on all the questions which you can pose in the chat functionality of this webinar. And then we have a question and answer session later on. I would also like to mention that this project is funded through the Horizon 2020 program of the European Union. And as an introduction, so you see here, that is my face here, and also Felix, who is supporting us in the background. One slide about the DBCO project. What are we doing? So we try to facilitate with this project, which lasts nearly for 3 years, facilitate the collaboration between European biogas industries, technology manufacturers, stakeholders, and from the emerging and developing markets in Latin America, in Asia, and in Africa. And we have two main aspects in the project. The one is that we use digital support tools, but on the other hand, we are also using face-to-face meetings for doing the knowledge transfer and the capacity building. Actually, at the moment, this is a little bit on hold because of the COVID-19 crisis, but we will catch up with these activities as soon as it is possible again. I would also like to thank all the project partners who are in the consortium. You can see the logos of the consortium partners below. Then coming to the agenda, we have now the welcome and opening. First, as announced earlier, we have the overview on the European biogas technologies presented by Mr. Frank Hoffmann from the German Biogas Association. Then we see some insights from Africa, especially focusing on South Africa, from Mr. Alberto Borello. He's the co-founder and operations. Sorry, I still have to deal with all this. Operations manager from Fountain Green Energy. And as a third presentation, we have the insights from Latin America, focusing on Argentina, presented by Jorge Hilbert from INTA. It's the National Institute for Agricultural Technologies. So we hear 3 very interesting presentations, and please feel free to post some questions into the chat. I hope that it will be a very nice afternoon session, very interactive as well, with some questions. As you have recognized, we are dealing with these technical challenges, but I hope that will be fine and that is all going to work. So with that, I just hand over to Frank, who's giving a presentation about the German perspective, the European perspective of biogas technologies, and if everything works with the technology, with our technology, then Felix, you can shift the screen from my screen to Frank's.
All right.
So Frank, the floor is yours, please.
Okay, yeah. Hello, everybody. Welcome to our second webinar on DBCO. As Dominic already mentioned, the presentation will be ordered in a way that for nearly 25 minutes, I will introduce the typical European biogas technology, and the other both presentation from Alberto and Jorge will focus on how will these kind of technologies, which are somehow general worldwide available, how will they be adapted to the local circumstances, South Africa and Argentina. In the next 25 minutes, we will talk about a technology overview, industrial-sized biogas plants, and I will start first to introduce myself. I'm working for the German Biogas Association. We have about 4,700 members in our associations. Most of them are operators and technical manufacturers. About 600 companies organized in our association, research institutions with a membership fee of the members. We have the salary for about 40 employees, so about 40 employees working on biogas topics. I'm one of them, and our typical scope of work is defining legal framework and technical standards, exchange of information, and of course advocating on level federal, state, and European level. But I should, how can I get this away? I don't know exactly. We will talk today about industrial-sized biogas technology. With this presentation, I would like to give you a short introduction in those technology in general. So we are talking about industrial-sized technology on the left-hand side, and a bit about Lagoon digester. In this DBCO project, we are not focusing on sewage gas. We are not dealing with domestic biogas or home digester systems and landfill gas. So the scope of biogas technology we are dealing with in DBCO is industrial-sized biogas plants. The typical feedstock, take this down. The typical feedstock which is used is organic municipal waste, bio-waste, industrial and commercial wastes, very important. Animal byproducts like excrements or slaughterhouse residues, vegetable byproducts, for example, leaves or stems of fruits. And this is a typical feedstock which is available for each kind of technology. The typical components of a biogas plants we are dealing here with industrial sized is the feedstock is collected, a little bit stored, usually pumped or transported in the main digester. That's number 5 here in the middle, where there's a reactor tank filled with liquid level and the biogas is produced within the tank. Usually stored on the rooftop of the tank, but there are external storages as well. This biogas can be used for electricity, heat, coal production, vehicle fuel, transportation fuel, or as biomethane directly, for example, to inject into the gas grid. There's a second product, not even energy, not even biogas. The second product will be the digestate, which has a very high level of value. With this slide, I would like to show you that depending on the quality of the feedstock, mainly depending on the dry matter content, there are different kind of technologies adapted to the local situation and to the circumstances. So when we are talking about dry matter content, on the left-hand side is 0%, that's pure water. With some dry matter content, we have the best technology, might be Lagoon biogas plants, wet digestion. If the dry matter content is rising, we are going to the right-hand side, then there are other technology better optimized. Dry batch digestion, for example, or above 30% or 40%, even incineration will be the best technology. And having said this, I would like to show you with the next slide some typical digester systems. How are they built up? The typical and main often used technology is a continuously stirred tank reactor, very often made of concrete or steel. There is additional insulation depending on the climate. We have usually a wet wall heating because the bacterial activity is best at the stable continuous temperature. Typical temperature are 37-40 degrees or thermophilic. In the digester roof, there's usually the gas storage. We have a digester mixer inside here, an agitator. The biogas is produced in the digester. I will not go through all details. The material feed into the digester, stirred, biogas is produced. That's simple how to make it. In reality, it looks like this, a concrete tank, stirrer, mixing system, wall heater. And the typical characteristics are continuously feeding. Feedstock can be used, any kind of feedstocks which are introduced. Agitation is usually necessary. Temperature can be about 40 degrees mesophilic or thermophilic, 50 or above. And that are the typical characteristics of a CSTR reactor. We come to the next technology. There are plug flow digester. The special thing about them is that the inlet is from one side. The material is mixed inside the digester, by that transported from left-hand side to the right-hand side. And by this transport through the digester, we have a somehow ensured retention time. Again, the biogas is produced in the liquid phase. Bubbles are going up to the surface, to the rooftop, and the biogas can be blown from the rooftop. That's a look inside. You see in the pictures that especially the stirring system must be very robust. While in the continuously stirred tank reactor we had before, there are usually some agitators. The mechanical stress on these agitators is extremely. And even on the right-hand side, you see a picture from the stirring system. So the characteristics is usually continuously feeding. All of feedstock can be used in this plug flow digester. The dry matter content can get even up to 45%. Agitation is very necessary, and the process temperature is somehow mesophilic, but very often thermophilic as well. These digester can be constructed in a horizontal or vertical way. But the reactor volume is usually a little bit limited because there are strong radial forces on this reactor. We come to the next system of biogas technologies. That's called a garage system, a dry fermentation system. So typically, if the garage is open at the beginning, then material, the feedstock, is brought into the garage, for example, with a wheel loader. After it's filled, the door of the garage is closed, and the material will stay there for about 1 month's time. The biogas will be produced. The advantage is the material can be stakeable, can be more dry material. It don't has to be pumpable. The digestion takes place in the garage. While the digestion takes place, there will be some water or liquids running out of the material, which are usually collected at the bottom, brought to a second digester, and this is a percolation tank. This material, the liquid material, has much organic load, so even about half of the biogas will be produced in the second percolation tank, and the water is sprayed on the top of the garage again to bring the bacteria, the feedstock, and the water into contact. That's the main information about a typical garage system. In reality, it looks like this. We have usually several garages, so that, for example, in this week, this garage can be filled, next week, in the next garage, next week, the after garage, to have a little bit more continuity in the biogas production. Characteristics is discontinuously feeding, typically for once a month. All kind of material can be used, and it's even suitable for stackable material. Pumpable material is not the best material here, but there's always a mixture. There's no agitation necessary, which is good for, let's say, if I think into maintenance cost, if there are no moving parts, then not so much can be damaged. So usually a very robust and reliable system. Typical temperature is mesophilic. And the fresh material which comes in is usually mixed up with some old, already digested material to have the bacteria in the system. We come to the next system, and these kind of systems are very often used in tropical regions. In some areas, for example, if you think about the effluents of a palm oil mill effluent, for example, in many tropical regions, there are lagoons where effluents from industrial production, for example, are stored. And the simplest way to build up a lagoon biogas plant is to cover this kind of lagoon. Of course, there should be a cover to the ground as well to avoid leakages into the soil and groundwater. And by having this kind of lagoon system, we have a biogas system which is relatively not too expensive. However, it has disadvantages. In reality, it looks like this, for example. That's a lagoon system working with the effluents of a palm oil mill effluents. But we see here we have a huge surface, and this is one of the disadvantages, that we have usually huge volumes which are not so easy to stir. Such system usually cannot be heated, but if it's in tropical regions, that's somehow fine. Safety aspects, of course, is a huge important point, because with this kind of huge surfaces in heavy weather conditions, rainy season, wind conditions, this might be dangerous. However, there seem to be some solutions to make lagoon biogas plants even relatively safe. But we should have in mind that lagoon systems are usually for high water content, 1 to 8% dry matter only. We have long hydraulic retention time. Agitation is a challenge, usually ambient temperature, which lowers the activity of the bacteria, which is, on the other hand, equalized by a high retention time. So the biogas yield could be okay. There are, of course, sinking problems with sinking material. So after a while, the lagoon will be filled up with sand or stones, for example. But it's a relatively cheap option to produce biogas. We come to the next topic, and this is a biogas utilization. So I introduced all these kind of technologies. Now we can talk about what can be done with the biogas. On the top left-hand side, we see the digester. This biogas can be usually used in a gas motor, very often a combined heat and power production, so CHP, but could be a genset as well, just electricity generation, which can be used locally or fed into the electricity grid. But additionally, this is the most typical use of biogas, probably having a gas motor electricity production. Of course, it's optional, an opportunity to use the biogas directly in a boiler for heating up industrial processes. For example, if you think on about breweries or slaughterhouses, it might be a better option to use biogas directly in the boiler. And the additional option to use biogas is to upgrade biogas to biomethane. Biogas itself consists mainly of methane and carbon dioxide and some other trace gases. If we separate these gases, methane from the other gases, we have nearly pure methane, which is very equal to natural gas. And with this biomethane quality, we can use the biogas, for example, in filling stations. We can see it on the right-hand side. I will sum up what I have said before we come to the other presentations, which will show us how to adapt that locally. To summarize, biogas plants are some state-of-the-art technology. In Germany, the main development is since 25, 30 years, so it's nothing new or unexperienced. We have in Europe about 18,000 biogas plants in operation, half of them in Germany. So it's very experienced technology. Biogas plants are optimized and reliable. Usually, if they are producing baseload energy about 8,000 hours per year, no problem. They last for about 20 years. Each biogas plant should be adapted to the local conditions regarding feedstock. That's the main important point. Size, of course, depending on the feedstock. The components have to be adapted. For example, the choice of the steering system, just to make one example, is a very important point. And of course, biogas are optimized according to the climate. Most important is that we have an experienced planner for that who brings in the functionalities of all components together. Having said that, I would like to close this presentation with some information material. So if you are interested to know more about how is feedstock transferred into biogas, how is biogas transferred into methane, about safety or the quality of the digestate, I would invite you to have a look into these kind of links. And that's my presentation. Thank you for your attention.
Yeah, thank you very much, Frank, for this introduction into the technologies, and you perfectly kept the time, so we are a little bit in advance, but that gives more room for some questions and answers. So if you have some questions, please post them in the chat function to Frank. Yeah, just as a short remark from my side, I think what is important is in all the renewable energy technology matrix or opportunities, biogas has a very special role because first of all, it not only provides renewable energy, but it is also a method to treat waste, that is organic waste, that was presented by Frank as well. And the other issue that is more and more discussed in Germany, where we have a lot of these biogas plants in operation, is that it really contributes to stabilize the power grid, because we have increasing shares of wind energy and photovoltaics in the power grid, and the biogas plants are more and more flexibilized. So that means that it really can be switched on and off according to the power demand. So that was just a little add-on from my side. So thank you very much, Frank.
But important point. So in Germany, we have, for example, 9,500 biogas plants. More than a third, nearly half of them are remote controlled. So the electricity provider can turn them on and off according to the need of electricity production.
Okay, thanks a lot. We do have questions, so can we deal with
Okay,
them?
very good. Perfect. Yeah. Yes, Felix, please.
So the first one is, which is the range of FOGs, so fat, oil, and grease, that can be used in a biogas plant?
That's depending on the time of adaptation of the bacteria. So if the feedstock should be changed, I would be very hesitant to feed in. First, start with a little bit, maybe 1% of these fatty materials, but it could be increased by the adaptation of the bacteria. I don't have a real limit, but I think that above 5% should be possible. But I have to admit, I don't know exactly what's the limiting end of that.
Okay, thank you, Frank. We have a second one. Does the heat from a biogas plant that is used to heat up the digester count as cogeneration, or is it only considered cogeneration if there are external end users?
It's a question of definition, and we see in Germany that the definition in the legal requirements are very different sometimes to other countries, so there's no general answer to that. Usually with the heat in a gas in an engine always has to be cooled, so there is always heat available, and this heat is usually used for fermenter heating. So that will be according to the climate conditions, and depending on the feedstock, about 5 to up to 20% of the heat of the CHP will be used for the digester itself. And if you call this already a CHP, I would say yes, because the electricity and the heat is produced and used. But the better efficiency has the whole system, of course, if there are other end users connected to that. And this is an important point to get additional revenue for the operator. Typically, revenue sources might be drying process in agriculture, or if there are industrial processes. This heat is very important, heat up houses. So in short, about half of the energy is only electricity, and the other half is heat. For a planner, it's very important to look into the heat, into the use of the heat. But in which country it's accepted as, let's say, legal CHP use, that's depending on the country.
Okay, thank you. I think we have time for one or two more questions. Is human waste, or could it be used as economical substrate for biogas production?
In principle, yes, of course. From a biological aspect, human waste is somehow, I think you are not talking about the in my waste bin, but yeah, what flows out of me. It can be used, of course, similar to, from a biological sense, similar to cow manure, for example, but of course there should be restriction about pathogen bacteria. These kind of bacteria are adapted to human livings, so it should be a little bit regarded to that. The energy content is not very much, but of course human waste can be used and the bacteria will be reduced very much. So the biogas process itself has a sanitization effect. What comes into the digester, human waste, for example, will be much more loaded with bacteria compared to that which flows out. So the digest state after digesting will be relatively free from bacteria, but of course there will be some that survive. And I come back to the first question. I think the share of fatty material can be even extended. I mentioned 5%. I think 10% or even more should be possible. I just thought about it again.
Okay, very good. So we're still very good in time. So we do have another 2 questions maybe. What are the possibilities for feeding fairly dry lignocellulosic biomass in a biogas plant, for example, straw?
In principle, yes, straw it's possible to digest it, and there are even some biogas plants. For example, in Denmark, I saw one which is mainly operating with straw. We should have in mind that the organic material which can be digested are chemical bound in some lignocellulose material, but there are options to, let's say, destabilize these kind of cells. So by temperature, by mechanical stress, if we cut it down very fine, then this material can be used. Of course, every kind of straw can be used in an existing biogas material, but typically if the straw length is long and the cells are like they are, there will be not so much gas yield in that. But if the straw is cut down, maybe a little bit heated up and pressed with some hydrolysis, for example, by that the availability of the organic material will be enhanced and the biogas yield will be enhanced much. So there are some technologies for that. I already mentioned hydrolysis. That's a point. Mechanical stress, temperature. That are the typical things to get more biogas from straw.
Okay, great. So we have one last question. Is a biogas plant only profitable if you produce both biogas and digestate, or can it be profitable if you only produce one product?
That's much depending on the local situation. I just give you some examples. In some countries, European countries, there are feed-in tariffs. And for example, in Germany, the first biogas plants based mainly on the feed-in tariff on electricity, and that was fine for them. Now the feed-in tariff went down and is not so much attractive anymore. So the biogas plants operator are looking for selling the heat. Heat is an important point. Value of digested, I come to that in a minute. Some other options for getting income is, for example, carbon credits. I know some biogas plants who get nearly half of the income revenue from carbon credits. So that's an important income source as well. Making the digestate into profitable value, that's a little tricky thing. The typical way to use the digestate is, again, depending on the region. In some region, there's too much nitrogen, for example, available in the region, and digestate or even manure from animals has to be transported out of this kind of region. In those kind of conditions, it's not so easy to get value of the digestate. But on the other hand, the fertilizing value is very high. So there are technologies, separation, for example, even microfiltration, reverse osmosis to get high quality concentrated fertilizer, which can be transported and sold. But again, that's depending on the local conditions. So what is the amount of feedstock which is used? Which kind of materials is in there? How much material do I have to separate and further treat? So on the local conditions that's important to decide. In Germany, I would say that many biogas plants are doing at least a separation for the liquid and the more solid phase. The whole range to pelletizing the digestate, concentrated fertilizer, that's not so often done. About 5 to 10% of biogas plants in Germany are doing that, the whole range, I would say. But mainly depending on the local circumstances, amount of feedstock quality, and the investment costs someone wants to do.
Okay, perfect. Thank you, Frank, for your presentation and your answers. And I head back to Dominic.
Yeah,
Pleasure.
thank you very much, Felix, for asking these questions or reading these questions. Thank you to all the audience for posing the questions. I have one additional question which very often pops up, is the question about the financial issues. So the question about the investment cost. Usually in Europe, the investment costs are rather high, also because of a lot of safety issues which we have to respect. So Frank, if you could say a few words on, you know, the investment cost of typical biogas plants in Europe, in Germany, and that
Germany,
would be then interesting to hear later on, perhaps also the perspective in the presentations from Jorge and Alberto. What are the differences regarding the costs for biogas?
Of course, that's an important point, because only an economic, valuable or good project will be realized in practice. The investment costs are mainly depending on the size of biogas plants. To give you some typical figures, a 1 megawatt electrical plant with all components, including CHP, including all material, steering system, everything together, will cost about 4 million euro, 3.5 maybe, about that, in that range. Smaller biogas plants are usually a little bit more expensive. For example, 100 kilowatt biogas plant will be in the range of, let's say, 5,000–6,000 euros per kilowatt electric. That's about the range. So we have the economy of size. The bigger the installation is, the specific lower are the investment costs. But again, it's much depending on the local system. If, for example, there's a hill and the material can flow down, then I could save some pumps. If there's already a digester tank, that helps reducing the investment costs. If there's already a storage tank, that helps. So the connection to the electricity grid or other options are important as well. But what I have mentioned, the figures are the typical investment costs is if everything has to be invested. There are options to reduce that.
Okay, thank you very much. We'll come back perhaps later on to this question. So now it's time to move to the next presentation from Alberto Borrello from the Fountain Green Energy. So please, Alberto, if you're able to share your screen, Felix, if you facilitate it, then perfect. The floor is yours, Alberto, if you show it on full screen.
Okay, thank you very much, Dominic, for the introduction, and thank you very much, Frank, for your very interesting presentation. So my presentation will be about the adaptation of European technologies in South Africa. Just a short introduction about myself. I am originally from Italy, and I'm living in South Africa from 2015. I've started to work in the biogas industry 17 years ago for an Italian company, and we have built many projects in Italy and in other countries like Argentina, Brazil, and China. most of the projects were landfill gas extraction plants or CDM projects when we were working abroad, but also some anaerobic digestion plants. So as I was saying, from 2015, I have started to work for Fountain Green Energy in South Africa. And from 2017, I am the Secretary General of the Southern Africa Biogas Industry Association. And from few months ago, I am part of the Council of the World Biogas Association. So the current situation in South Africa is represented by this map, where that is showing that currently there are about 30 megawatt of industrial scale biogas plants that are including also some landfill gas power generation plant, and something around 300 micro digesters that have been built all around the country. Most of the anaerobic digestion plants, as you can see, have been built very close to the biggest cities like Johannesburg, Pretoria, Cape Town, and Durban. South Africa historically has been one of the first countries that has developed anaerobic digestion from wastewater treatment plant. And in Durban, the city where I am living, in 2006 has been built the first gas to electricity and CDM project in Africa. As Frank was showing previously, there are different technologies that have been used and are existing in South Africa. We start with the micro digesters, and we have seen that there are about 300 plants built like these. Small scale industrial plants, and those are those pictures are specifically for 3 projects built in South Africa. And then big scale industrial plants, like you can see in those 2 pictures, that the first on the left is producing electricity, the second on the right has been designed to produce biomethane. So what is and how the application of the European technology has worked in South Africa? This is a picture taken from one of the plants that we have built in Cape Town, and this plant is collecting municipal solid waste for the production of biogas. This is a very complex material recovery facility, and the technology has been supplied by different European companies. This is another section of the plant, anaerobic digestion, flaring, and pre-treatment of the waste. And this is the upgrading plant for the upgrading from biogas to biomethane and the separation of the CO2. Those are the tanks for the CO2, and this is the building with the upgrading plant. So what have been the challenges in some of the projects that we have done or we have built in South Africa? First of all, the technology is available. The technology, as Frank was also confirming, is proven. So there are no questions if the technology can work, but how that technology can be applicable in a project in a developing country, this is the question. Is the local industry ready for the technology? How the technology can be applied? And the fact is the latest technology is not always the right solution. Like an example, some of the project or some of the discussion are thinking that the latest technology in Europe is the upgrading into biomethane. The biomethane upgrading plants are working perfectly in Europe, so there is no doubt that they will also work as well as in Europe, in South Africa or in other countries. But is the country ready for that specific technology that is very advanced? Can we go from disposal of waste into a landfill straightforward into the construction of an upgrading plant for the production of biomethane? Can we skip all the steps that has happened in every country where we move from the disposal of waste into organic into the landfill through the extraction of and production of electricity from the landfill gas, and then waste separation and anaerobic digestion for power generation, and then the next step and the latest one is the upgrading into biomethane. Another aspect that we need to take into consideration is the accessibility of spare parts from a time and cost perspective, considering that the business plan of a biogas plant is influenced, of course, by the capex, but the opex has a big role in the feasibility, and the exchange rate and the variation of exchange rate is something that need to be taken into consideration. So the technology we must keep the technology as simple as possible to reduce as much as possible the risk due to the fluctuation of exchange rate. And then the technology that can be used in the project need to be very flexible, because especially in a developing country, the legislation can change. And every time that legislation changes, a big change, like last year in South Africa has been introduced the ban of the disposal of liquid into the landfill. So there is a big availability of liquid fraction for anaerobic digestion. So all the existing plants can be reconverted or can be modified to receive liquid with a high organic content. That, of course, is a very good opportunity. So other challenges is that when you design and when you develop a project, you expect to have organic that you can use, like in these pictures, with very, very high content of organic, more than 90% if it is a pure organic kind of waste. Sometimes the reality can be very, very different. And maybe you find out that your waste is like the one that you see in the picture. So technology is able to deal with these kind of waste, but the technology can't be so flexible that can go from these to these. It is not a technology problem. It is something that needs to be addressed during the development, like to do a proper characterization of waste, to be sure that your technical choices will be the right one for the specific project. So who is responsible to choose the right technology? Now, as Franco was showing, there are so many different technologies available. All of them have been tested for 10, 15, 20, and maybe more years. So who has the responsibility? The investor, the developer, the EPC contractor, the plant owner, the supplier, or the operational and maintenance team? Who has the right skill and experience to advise and take the right decision? And another point is how and for how long the operational and maintenance team have been trained to use that specific technology. So, and the last point, from an health and safety point of view, there is no chance to take any shortcut. before there was a discussion saying that in developing countries or foreign market, sometimes the cost for the construction and operation can be lower because the requirements from health and safety point of view are different. But when we talk about health and safety, there is no discount. So another important thing is that many times at the beginning of the project, people have in mind this kind of situation where you base all your assumption on a separate collection and a perfect organized system, and then after some time you find out that the situation is slightly different, and maybe you find this kind of solution. So what are my recommendations? As I was saying, the biogas technology is proven. It is important to create confidence and credibility to the investors. Technology works. Many times people address problem during the operation of the plant to the technology. That is completely wrong. Maybe there has been the wrong decision about which is the right technology that need to be used in that specific project. So there is no chance to take any shortcut during the development stage. It is true that every technical problem can be fixed during the construction or during the operation, but at what cost, and what will be the impact of this shortcut in the business plan during the operation? Is that compatible to the business plan? Is there enough are there enough allowable to fix eventual problems, or the developer has just taken some shortcuts to achieve the financial viability and then just push the problem during the operation? Another important point is that the technology supplier must guarantee a local presence beyond the construction through local partnership with the local companies. The assistance during the operation maintenance is extremely important to reduce the shutdown time for a plant. And that can happen only if the technology supplier has a local presence, directly or through a local representative. Another point is that the technology supplier is responsible as much as the client to the success of the project. It is true that there are contracts in place between the client and technology suppliers, where normally those contracts, they identify very clearly who is responsible for what, and they create a very clear boundary. But the technology suppliers is responsible to the success of the project. Normally, technology supplier, not normally, but many times, has a lot of experience previously acquired on other projects. You need to share this, you need to address, you need to evaluate if that project has taken into consideration and all the criticalities has been addressed properly. So the technology supplier doesn't have just to supply the equipment, but must offer training to transfer the skills to the operation and maintenance team for a successful project and for a successful industry. The reason of this is because if a project fails, the reputation damage is for everyone. It's not just for the specific project. The reputation damage will be for the developer, for the technology supplier, for the company that has built the plant and is operating the plant. And there will be the reputation damage to the whole biogas sector for the country. So technology, we have seen in all these slides that is proven. The point is is that the right technology for that specific project, how the technology supplier can share these risk and how it can help and support to create a successful project. So these are my recommendation, and this is everything from my side. So I thank you very much, and now I am available for all your questions.
Thank you very much, Alberto, for this very interesting presentation. Also talking about the costs a little bit, and that it's not necessarily cheaper in your framework conditions. So I directly hand over to Felix, who sees the questions from the audience. Felix, are there some questions?
Yes, there are. So the first one is the challenge of mixed feedstock, or does this challenge also apply for industrial waste? If not, would you suggest to jumpstart the biomethane technology to fusion firstly in factories or industry, so on the factory level, or even before?
Okay, so the challenge of the quality of waste is certainly one of the biggest challenges in South Africa. Currently, if we talk about municipal solid waste, there are only 2 cities where the municipality have started separate collection, and that is the most important thing. My experience is that many times in Europe, there has been several projects that were trying to separate the organic from municipal solid waste to produce compost or to produce to extract the organic for the anaerobic digestion. But the big change there has been when the municipality have implemented the separate collection, because then it reduces the risk that you won't be able to separate all the recyclable from the municipal solid waste that will be contaminated, and then it will reduce the cost to dispose everything that cannot be then resold or reused as a recyclable. If I understood properly your question, if we talk about the possibility to use the waste inside the industrial plants, this is one of the most common kind of plant that have been developed in South Africa, where the food processing industry have evaluated the cost to dispose waste from their process, and that waste sometimes was considered hazardous waste. So the cost for the disposal was much higher than a normal municipal solid waste, because they were not allowed to dispose that waste in municipal landfill. So in those specific business case, they have implemented anaerobic digestion, and they have offset the cost of the disposal of this hazardous waste into hazardous landfill, and those are the basis of a few successful anaerobic digestion plants here in South Africa.
Okay, thank you. We do have another question. Are there any promising feedstocks for biomethane biogas production that are unique for South Africa, for your country, for your conditions? And if yes, what are the challenges this posed to the project developers?
Sorry, you were breaking up a little bit. Can you repeat the question, please?
Of course. Are there any promising feedstocks for biogas production that are unique for South Africa and for the conditions there? And what are the challenges this posed to project developers?
Well, currently there is a very wide and big availability of the feedstock for anaerobic digestion here in South Africa. Through the Southern Africa Biogas Industry Association, in the last 6 months, we have done a very deep analysis on the availability of feedstock and an analysis of what is currently viable. The conclusion of this analysis is that the total amount of anaerobic digestion plant or biogas plant, including also landfill gas plants that can be it is viable at the current condition. It is about 500 megawatt, and as we have seen, we have currently only 30 megawatt of plant built. So there is a quite wide variety of feedstock available, and that can go from food processing industry, and I would say that this kind of industry is quite active, and there are currently project under commissioning and project under development, because they have a quite high consumption of electricity, and so they can reuse the electricity that they can produce. And the driver of the project is not always the availability of feedstock and the cost of electricity, but also the availability of the grid. One of the things that is particular for South Africa is that currently we are going through a period of load shedding. That means that the power generation is not enough to cover the requirement of electricity. So there is the need from some of the big companies to become, or to try to become, as much as independent from the grid, especially during the period of the load shedding. So there are also different drivers.
Okay, thanks a lot. So we have one more COVID-related question. Should the government ease out the waste regulation for factories so that the economy could recover faster?
There are several proposals to the government to address properly the right use of organic waste that will really simplify, from a certain point of view, the development and the construction of a new anaerobic digestion plant, and will open the possibility to the industry to invest and resolve some of the anaerobic digestion problem in the country. So these will always, as happening in every country, take quite a lot of time, because every time that there is a proposal in change of legislation, these need to go through a several long process. But that has been addressed, and hopefully during the next year there will be the government will adopt some of the new legislation proposal that we have done, and that will certainly help the growth of the anaerobic digestion sector.
Okay, great, thank you. These are the questions for now. We're rather good in time. Maybe we can, or if you have any questions from the panelists, feel free to.
Yeah, my proposal, thank you very much, Felix. My proposal would be to just continue with the next presentation, and then if there is a time at the end of the webinar, we can have a full discussion among the panels if there is no more questions from the audience in the end.
Perfect.
So okay, so let's move the continent, moving from Africa to Latin America. Jorge will present us the news about Argentina, the Argentinian biogas sector. Jorge is from Inter. Please, Jorge, if you share your screen, the floor is yours then. Yes, you just have to show.
Yes, but now I'm okay. Good morning from everybody. Although we changed from continent, we're still in winter here with 1 degree. So I'm going to give you some insights from my country regarding the news and the possibilities of European technologies here. So As you can see, we are really in the far south of the world with a population of nearly 45 million people and a huge surface of 2.78 square kilometers and a very low population density. So this gives us a great challenge when we talk about technologies and adaptation to technologies, since in the same scale we are looking here at Europe and Argentina. So we are covering from tropical areas to Antarctic situations, different agroecological and social regions. So technology must be adapted and work well in very, very different situations along the country. So I belong to INTA, the International Institute of Agricultural Technology. We cover the whole country. We gather in the same organization, extension and research facilities. We have more than 50 experimental stations and nearly 300 extension agencies coming from the far north to the far south, with nearly 7,000 people working in INTA. So just giving you an insight of the agriculture sector in Argentina, where biogas technology is being put in place as the principal area. As you probably know, one of the characteristics is we are under no tillage technology in the country, with more than 80% of the surface under no tillage. So that gives us an additional challenge to how to deal with digestate and how to incorporate them into the soils. Regarding the agriculture production at all, we have a very intensive application of technology in the farming sector. We have a tradition of farms knowledge shares and a permanent innovations. We don't have a subsidized agriculture. We have a very heavily taxed, overtaxed agriculture. So they have to be very keen and adjust the numbers to keep up in the business. And so also they have adopted precision agriculture and precision management of nutrients in their soils. Together with that, there is a very high-tech and mature farm machinery industry and technology development on the mechanical side, on the electronic side. And this also completes the environment of where biogas technology is landing and how these factories are adapting and adopting and introducing themselves into this new market that is arising in Argentina. So some of myself, I have a long story in biogas, and you're seeing me here in one of my first workshops in 1983. So has a long way on biogas systems in the country. Looking here at our first digesters in that decades and our first published manual on the biogas sector. So regarding the feedstocks and the availability of material in order to have biogas plants here. Oh, I lost the presentation. I made a mistake here. Are you still seeing the screen or no? Okay. I stopped seeing that. So I stopped seeing my screen. I don't know why. I made them. I tried to. I cannot. I don't know why I can't see my screen anymore.
Okay, Jorge, I just take it back and give you again the right to share it, okay?
Okay. Okay. Okay, regarding the biogas sector, we have more than 150 digesters of different sizes. In the country, there was a survey regarding their characteristics some 5 years ago, and most of the plants, there were more than 70 plants surveyed. More than 80% was not using biogas regularly. They have difficulties in the temperature control, in the mixing systems, and so on. And in that time, there were detected more than 20 technology providers and no security measures in the plant. So 5 years ago, there was a launch of a new program, and that changed the biogas history in the country. You have there the different rounds and the new plants that were put in place. Six biogas plants in the first round, 32 in the second, and 14 in the third round that was launched during last year, and that dots there represent the main areas where the plants are being implemented. So this is an extraction of the energy, the Ministry of Energy website. You can go there and see the characteristic of each plant. They are ranging between 1 and 5 megawatt in size, but most of them are in the range between 1 and 2 megawatt. That's Renewable 1 and 2 projects that have been constructed, and most of them are already in operation. And that's the last core that are in the stage of commissioning and signing the final contracts, and they should have start construction this year, with the same range of sizes. So for this workshop, we made last week a survey, an online survey between the developers and the construction. We have 11 developers answering our quest. That they have 35 constructed plants. So this we are covering nearly 90% of the new facilities, biogas facilities, most of them having some European technology parts in them. So we first ask how many plants they have in their background, and more than 5, 27%, and around 3, 36%, and 27% only one plant in their background. So regarding the type of technology they acquired from Europe, you see there digester, gasometers, mixers, pumps, engines, control systems, membranes, and blowers. Those are some of the components they are importing from Europe. Regarding which type of equipment have no problems at all during the construction and implementation phase. Nearly half of the components of European origin has had no problems at all. 36 had some problems, and the rest are plants that are not already in operation. So we ask what type of equipment presented problems, and you see there some regarding stainless steel equipment, some regarding control systems, hot water, presenting cavitation problems, water slopes, pump and control systems, agitators and pumps, and pretreatment equipment not suitable for the feedstock they were managing. Those were what the developers answered. how they solve the problems. No, we were inquiring how they solve the problems. Half of them solve the problems with local providers, and the other half integrated the solving of the problems between European partners and local partners, and only one said he couldn't yet solve the problems he's facing. So we asked them what type of technology they are willing to still incorporate from Europe. Most of them are looking for specific parts and components. Some they say they could be independent now, and a little part are looking for integrated systems. So we asked them if they were able to establish partnership between local providers and European providers, and nearly half of them, a bit more than half of them, said yes. So they were capable of managing to unify European with local providers. So we asked them which was the highest, the biggest challenge they face incorporating European technology. Most of them highlighted the price, and the rest also highlighted the difficulty in importing parts and components from abroad, regarding the different paperwork they had to go through. And one said adaptation to local needs. So at the end of the survey, we asked they could freely write down about their experience and their forecast and their vision about the European technology. So you see there straightforward what they have written about. Most of them had expressed their good experience with European suppliers, someone especially with German language difficulties, and also most of them are proposing ways to improve the synergy between local and domestic suppliers and European suppliers. Some of the biggest developers that have more than 5 plants constructed, they have already managed to select suppliers and reliable suppliers from Europe, and they are working fine today. So in March, before the lockdown started in Argentina, we were able to make some field trips and visit some developers in the main developing area of biogas in Argentina. Here we're looking at the different sites we visit. We covered 6 biogas plants and 3 companies in Rio Cuarto, Timbúes, Venado Tuerto, Pergamino. We're looking there. Some of them have nearly 90% European technology. Some ones are mixing, and the Timbúes plant, for example, in the right-hand bottom, is 100% Argentine technology. So we highlight here what we've seen and what we talked with them during our visits. We highlight here some problems regarding equipment and technology for specific feedstocks and pretreatment of certain material. And most of them are foreseeing that they will need help and input of European technology in upgrading digestate, in obtaining higher value products from the digesters, in the field application using precision agriculture and precision nutrient management techniques as a nutrient management methodology, and also they keep on raising up the joint venture need with local industries. As INTA, we are performing also life cycle assessment studies on commercial biogas plants in the country. So we see here a new challenge regarding the environmental requirements and the environmental performance of biogas plants. We see the importance of synergy in order to reduce emissions. Some plants are being placed beside bioethanol plants here in Argentina, where there is a synergy between electric thermal use of energy and intelligent use of energy produced and the reduction of methane emissions. We also are active in an initiative called Biogas Done Right. We are developing with the Italian Biogas Association and Michigan State University. Here we're looking at biogas in an holistic way, looking at the continuous soil coverage, the economic stability, the residue valorization, the organic matter increase. There is a huge area here to grow in biogas technology in the country, especially looking at biogas as a negative carbon technology. Just an example, I bring here a possibility of joint ventures between Argentine companies that have developed, for example, this company have developed compressed natural gas and liquid natural gas and virtual gas grids. They are using this and they managed to reduce 600 times the volume of methane reaching diesel energy density. They are placing this in especially in the mining sector, but they are looking into the biogas sector as a new market and a new possibility to enlarge the application of this type of technology. So ending up and looking at the actual situation and forecast, we see that the Renovar program with different calls have produced this new market. We have a new administration now in place in Argentina. They say they will respect the contracts of the Renovar program, and they will go forward with the last call, signing the contracts and permitting the last plans to be constructed. There is uncertainty regarding the future actions they're going to make and what plan they're going to put in place. The Probiomasa program of the Ministry of Agriculture is very, very active and is still very active in the biogas sector. There are a huge amount of information there, GIS format information regarding the possibility of feedstocks in the country, and also specific studies on biomethane, on electricity, and so on. We as an organization are continuing our project focusing on design and laboratory support. There are new companies in the market that are growing and they're acquiring more experience and in a mixed way with the European partners. There is an increasing lobby to promote biomethane in the country as the old biofuel law is fading out at the end of this year. Now there's a strong discussion to include biomethane together with biodiesel and biomethane as a possible new biofuel in the country. And also there is an increasing interest and awareness on biogas benefits in the agriculture and the agri-industrial sector. And of course, economic instability is always an issue in Argentina, and especially in this pandemic era we are facing. So muchas gracias. Thank you for your interest in this insights from my country. You have here my mail if you want to deep into information, and also I'm giving you my Google site and the YouTube channel. You can see there a lot of information and films we made on different biogas plants running in the country. Thank you very much.
Jorge, thanks a lot.
Thank you very much for this presentation, and also especially from these results from the different surveys. That was quite interesting to me, probably also the other participants, especially from the European side. So, Felix, are there some questions?
Yes, there are. Maybe we do have some time for one or two.
Yes. Mm-hmm.
The first one is, it seems Argentina is moving quite fast into the next stage of biogas, so including biomethane, bioethanol, etc. How do we know that a country is ready to move forward into the biogas technology? Are there any standards that could be used?
No, there are no local standards regarding the plants themselves. They are using the European standards for security measures. We are still pending that. There has been some legislation regarding the digestate use. This is difference between the provinces of the country. Each province has a special legislation regarding the final digestate use on the fields, and regarding the use of biomethane in the grids. If it's upgraded into methane, the same rules for the methane grids apply in the country. And I know that there are some initiatives to promote specific legislation for biogas without upgrading them. Regarding the compressed natural gas in transport, Argentina has more than 2.5 million cars running in compressed natural gas technology. So there is a huge legislation and technology developments regarding that possible use of biological compressed natural gas.
Okay, thanks a lot. Do we have time for one more question? Otherwise, I would hand over to Dominic. One more question? Okay. Argentina is currently moving with the or developing the biomethane law. Could you please share what will be stipulated in the law and what is different with regard to the biogas law, if there are any?
Yeah, especially what they're trying to move forward is that biomethane has a participation in the local market. Argentina is not self-sufficient in methane now, so we are importing some from Bolivia and some as liquid natural gas from the Arabic countries. So their target is to replace that imported section of gas with local biomethane to promote the industry and to promote the job creation in different parts of the country. They're highlighting one of the characteristics of the biogas sector, that is spread all over the country and is a technology that can provide new jobs and high value jobs to the communities in different parts. That's the main target of the biomethane. We have presently 12% mandatory blend in our fuels with biodiesel and bioethanol. So there are very big players there working, and this is a Cinderella trying to get into the into this market.
Thanks a lot, Jorge. I think we're perfectly in time, so the final words are yours, Dominic.
Yeah, thank you very much, Felix, also for this excellent moderation of the questions. Before we end this webinar, Felix, I kindly ask you to allow me to share my screen. In the meantime, I asked the three panelists for a very short statement, final word. This was not pre-announced earlier or discussed, but I would like to have your opinion on what would be your wish in terms of European and American or African cooperation. Like, if you would have one wish, what kind of wish would that be in terms of biogas cooperation? So if you answer, please feel free to answer in short sentence, and I will share my screen. Yeah. Perhaps start with I don't know.
First.
Yeah, Jorge, please.
Okay, from my side, we foresee a strong possibility in certain areas of cooperation of certain parts. We see that very rapidly local developers are acquiring big experience in biogas. It's not worth to import some parts that can be constructed or provided by local providers, but there are, especially on the new areas, as I highlighted, regarding the digestate treatment and so on, and the control systems, etc., that we can still have this joint venture with European partners. And regarding the cost, it's always as you mentioned before, I wrote here 4 million per 1 megawatt plant. In Argentina, they are around 2.9 to $3 million per megawatt. Those are the costs of the new plants being implemented.
Okay, thank you. That was a little bit more than one sentence, but thank you very much for the very interesting answer. So, Alberto, what's your main wish? You have to unmute yourself.
Okay. So your proposal to create this cooperation is certainly interesting, and I think that we can summarize saying that let's work together for a sustainable biogas industry.
Okay, that was very short, and I fully agree. Thank you. The final wish is yours. You have to unmute.
Yes, my wish is somehow very similar to that of Alberto. So we wish that we learn from each other, that European technology providers learn how to make biogas plants more economic feasible. And on the other hand, that there's more capacity and local know-how in the other partner countries, so that we in some have a growing demand of bioenergy and biogas especially.
Okay, thank you very much for that. I hope that you see my slide. Do you, with the series of webinars?
Yes, I do.
Okay, very good. So this is just the announcement for the next webinar, which will happen on the 7th of September. And the topic is mainly about feedstocks. There was one question today about the feedstocks in South Africa, for example. We'll discuss all that in the next webinar. It's about feedstock characteristics and also the potentials. So If you have any more questions, or you can always approach the different consortium members, which you can find here on the DBCO website. There is also a list of all the upcoming webinars, so please feel free to visit the webinars and also our social media. So with that, I kindly thank all the presenters. I thank especially also Felix for setting up the webinar. I thank Sinja for the cooperation, and Johannes, and all the participants for joining. Thank you very much and have a nice day. Take care about yourself. Stay healthy. Goodbye.